Now let's see the concept of memory interleaving. So what we mean by memory interleaving is, assume that we want to read, generally how a program reads some data is, it is not going to ask for just one word, it generally asks for a consecutive words, let's say k words, or let's say 4 words or 10 words. Now what happens is, we in general don't refer to just one word from the memory. If we are going to get a word, then we will be getting many, we request many words, like let's say this is word number 1, word number 2, word number 3, word number 4, right? Now if all the 4 words are present in single memory module, then our program is going to be slower. The reason is, you have to read word number 1 and then word number 2 and then 3 and then 4, one after the other, right? So if you see this, let us say access time, memory access time is maybe 100 nanoseconds, right? Then what happens is, for the first word you have to spend 100 nanoseconds, and for the second word you have to spend 100 nanoseconds, and for the third word you have to spend 100 nanoseconds, and for the fourth word you have to spend 100 nanoseconds. Therefore 100, 100, 100, 100, 400 nanoseconds will be taken. Now instead of this, if you would have distributed the words in such a way that all these 4 words are present in 4 different modules which can be accessed parallelly. So what I mean to say is, instead of having this type of distribution, if you would have had this type of distribution, which means even though we are having 4 words, let us say 4 words are distributed like this: in first module 1, second module second one, third, fourth, right? And then 5th word is here, 6th word is here, 7th word is here, 8th word is here, something like this. Then what happens is, you will be able to get the first word, second word, third word, fourth word parallelly, isn't it, in 100 nanoseconds. Therefore parallel execution is definitely possible there. So that is what is the concept of memory interleaving. Memory interleaving means we are going to have various memory modules, and on each module we are going to place, we are going to distribute the words in such a way that when I operate them parallelly, I'll be getting efficiency. Now the same concept can also be implemented in the hard disk as well. In the hard disk, I hope that you remember the concept of the cylinders, right? So or at the end we are going to talk about it again, but still I'll just give you a brief overview here. Now in a cylinder, let's say hard disk is composed of many surfaces or platters. Let us say there are many platters like this, placed one upon the other. Now instead of putting the data completely from 1 to 100 words in one platter, if we can distribute first word on the first platter, second word on the second platter, third word on the third platter, fourth word on the fourth platter, and if every platter is having its own read-write head, then just during the time in which you read one word from one platter, you will be able to read all the 4 words from all the 4 platters if we have those many read-write heads. Got it? So this is called as memory interleaving. Now let's see the concept here. So what is the main advantage of memory interleaving is, it reduces the average access time and it improves the data transfer rate, isn't it? Now in case if you want to implement this memory interleaving concept, you are basically supposed to have some memory modules, which means the entire memory has to be divided into various modules. Let us say module number 1, module number 2, so on, module number k, or 0, 1, 2, so on, m minus k. Now whenever an address is generated by the CPU, now CPU need not know where and how the memory, the words are saved. It will just generate an address. Now that address has to be interpreted by the implementation, and it has to be appropriately matched up with the words. So what I mean to say is, given an address, you should be able to resolve it in such a way that you should be able to get the memory module number in which that particular word is present, and within that module where is the word present. Got it? See, so what I mean to say is, you should divide the address into 2 parts in such a way that some part of the address is going to identify the module in which that particular word is present, and the second part is supposed to find out what is the word in that particular module, right? And now this module which is giving us the memory module number may either be at the beginning of the address or it may either be at the end, right? Now let us say it is at the beginning. Then what happens is, first we give this part to the decoder. Now decoder is going to take some time, let's say 4 nanoseconds in this case, and decoder is going to generate which memory module, from which memory module we should be reading the data or writing the data to. Now once that particular module is selected, then it will take the memory access time for that particular module to read that word. Now let us say memory access time required by each module is 100 nanoseconds, then the total time required in order to read one word is going to be 4 nanoseconds plus 100, which means 104 nanoseconds. But it might feel that this 4 nanoseconds is a overhead, but when you think about reading many words in parallel, you will see the performance here, you will see the efficiency here. Now just see this. Now in order to read the first word, what happens is 4 nanoseconds will be spent decoding the address, finding out the module, and then identifying the exact module and giving it the read write request. And 100 nanoseconds is spent by that module in order to read or write the data. And once you have done this, now your decoder is free and you can send the request for the second word, in case second word is not in the same memory module. And also we are going to organize the words in such a way that consecutive words are not going to come onto the same module. That is what we are going to do. And now for the second word, if it is not present in the same module, then 4 nanoseconds will be given to to find out which module it is in, which means for the decoding the address, and then 100 nanoseconds will be spent by the second module in order to get that word, right? So see this is the performance improvement we are getting. Earlier it was 100 after 100 after 100 like this, right? Now if you see this, we are able to overlap. Now how is this overlapping being done? Because this is from one module and this is from another module, therefore I can do it, right? So it is same as pipelining concepts, which you will see later. And now the next one is again 4 nanoseconds and again 100 nanoseconds, right? And for the next word is again going to be 4 nanoseconds and again going to be 100 nanoseconds. Likewise, if you are going to read let us say k words, then what is the total time taken? The total time taken will be equal to, see this, so 4 plus 4 plus 4 plus 4 so on, k times you will be getting this 4 nanoseconds overhead. And after this k times, for the last word you have to count this, isn't it? See, in this case, in order to get 4 words, you have spent 1 2 3 4 4 into 4, 16 nanoseconds plus 100 nanoseconds. Got it? So how many ever words you are going to read, it is just simply going to take k into those 4 nanoseconds plus 100 nanoseconds in this example. And if you are changing these numbers, you have to change these numbers. Got it? And in case if you are not using this method, if you use the normal memory without having interleaving concept, then you will end up having k into 100 nanoseconds, because you will not be able to overlap any of the operations, and for each word it is going to take 100 nanoseconds. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%. And IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.